Hey guys, what's up? Welcome to our third part in our series on our deep dive in oligopoly. In this video, we're going to talk about Bertrand Equilibrium. Let's go. So what we're going to cover in this video is that we're going to discuss Bertrand Equilibrium with homogeneous products. That means we're going to be competing with prices with the same product, and that's not really very interesting. And we're going to be talking about Bertrand Equilibrium with differentiated products in that case. So Bertrand Equilibrium is a scenario where our firms compete in terms of prices, as previously mentioned. In the case where the products that the firms sell are homogeneous, meaning that they are the same, the equilibrium concept is not very interesting. Consumers simply buy from the firm selling the product for the cheapest. Thus, the demand faced by firm I, where I is, for firm 1 and firm 2, is this following piecewise result where you're able to capture the entirety of demand by simply charging less than your opponent at a point in time. So this is kind of it's not really strategic. It's kind of up to luck and up to your beliefs about the other players' cost structure here, and it's a kind of a winner take all sort of scenario because if you think about it, what are the odds of you going in posting the same price as someone else when you haven't observed a history beforehand? So let's now consider the case where we have two firms selling a similar product, but we have the following demand curves where the products are symmetric in the following case. So we have two goods, good I and good J. They're differentiated. We can think of them as two different brands of sneakers. And the logic from this demand equation here is that we go and we have this point where charging more for your own product is going to decrease demand, but if your opponent goes and charges a higher price for their product, right, that's actually going to increase demand for your own product. So if we define the marginal cost for each firm being defined as 2, meaning that it costs 2 units or $2 for each amount that you go and you produce, or each unit that you go and produce, what is the Bertrand equilibrium in this context? So there's 3 steps here. We're going to go and step number 1, write firm 1's and firm 2's profit function. We're then going to take the first order conditions and solve for each of the firm's best response functions. And step number 3 is that we're going to take one of the best response functions and sub it into the other to obtain our Bertrand equilibrium. So step number 1, writing our profit functions over here. Since they are the same, I'm just going to be using a subscript I for our profit function, and we just go and we put that in there. Our next step is that we're just going to take our first order condition, which is the derivative of our profit function for firm I with respect to the price of its own product, and we're going to go and solve for pi star, which is our best response function, and we see that it is this thing right here. Pi star is equal to 54 plus pj all over 4, where I is, again, for firm 1 or firm 2, and I is not equal to j. So for step number 3 is that we're going to sub one best response function into the other to obtain our Bertrand equilibrium. Now we know what pj is because it's the same thing as pi, just that it's a change in subscript because our demand curves are symmetric to each other. Just working through the algebra, we go and we solve for pi here, or really this is for both firm 1 and firm 2, and that's going to be 18. In this case, both firms are going to be charging $18 for each one of their products. So this is how you solve for Bertrand equilibrium for our case of differentiated products. I showed you what it looks like in the case of homogeneous products. I hope this video helps. Take care.